So nearly there, 15. I've got a cos x here. We need to divide everything by cos x to start with. And so we're going to have dy by dx plus y, or sine over cos is going to be a tan, and 1 over cos is going to be a sec there. We need to times by the integrating factor, looking at a tan x there, and you know the integral of a tan x is a sec squared x. No, it's not. That's what it differentiates to give. The integral of a tan is the ln of the sec x, isn't it? And so our integrating factor is e to that. So we're timesing by sec x. So sec x dy by dx plus y tan x sec x equals sec squared x. So the product rule here is going to be a sec x times by a y, isn't it? Because sec x goes to sec x tan x, and there, that's fine there. There's the sec squared. Integrating both sides of that gives me y times by sec x equals, and sec squared, I get this right this time, that one goes to tan x plus c. Divide both sides by sec. Dividing by sec here is timesing by cos, so the cos cancels there, so I've got a sine x there, and I'm going to put c cos x there, I think would be the nicest way of doing that. We've got to put some numbers in, have we? We've got to put in pi and 3. So when x equals pi, y equals 3. Stick a 3 in there. Well, the sine of pi is 0, and the cos of pi is minus 1. And so I've got c equals minus 3 there. And so my particular solution is y equals sine x minus 3 cos x. Minus 3 cos x. Yeah, let me pause there and read the next bit. Okay, so part C is coming in here again at that part there, but this time we've got x equals pi over 2 and y equals 1. So I've got 1 equals the sine of pi over 2, which is 1, plus c times now the cos of pi over 2 is 0. So 1 will equal 1, so point on the curve. Doesn't matter what c is there, it'll work. And for the other one, we get the same sort of thing, I think. So we've got 3 pi over 2, and y is minus 1, so stick a minus 1 in there. The sine of 3 pi over 2 is minus 1, and then c times the cos of pi over 2, c times 0. So therefore the points on the curve again, that this doesn't matter what c is. If c could be any value at all, that point will always be on the curve. That point will always be on the curve there.